Okay, so for question 3, again, we want to isolate for either x or y in one of our equations, and then use substitution to solve. So I'm going to start by labeling my equations again. So I'll call my first equation equation 1, and I'll call my second equation equation 2. Because this time around we're not as lucky, we don't have any of the equations as x by itself or y by itself. So we do have to isolate for either x or y. Because equation 1 looks like it's easier to isolate for, I'm going to choose to isolate for equation 1, and I'm going to choose to isolate for y. So for equation 1, I have 3x minus y equals 7. So I'm going to move 3x subtract it from both sides. So I'll subtract 3x from the left-hand side, and because I do that, I have to subtract it from the right-hand side. And when I do that, what I'm left with is negative y equals to negative 3x plus 7. Now from here, I want to get rid of my negative y, so I'm going to divide every term by negative 1. And when I divide every term by negative 1, well, there's pretty much a negative 1 in front of the y. That's why it's negative y. So negative 1 divided by negative 1 would just get me y. Now negative 3 divided by negative 1, that would get me, because it's two negatives become a positive, so that should get me 3 over 1 x. And then because there's a negative here for the negative 1, 7 divided by negative 1, I would actually move the negative up. So this can be written as minus 7 over 1. Now what I can do is I can simplify and reduce. Remember, I don't want any like integers that could be integers in like fraction form, like to finish off. So I'm going to reduce some more. So 3 divided by 1 can be written as 3. So because it can be written as 3, I would actually write it as 3. So 3x. And then because 7 over 1 can be written as 7, I would write it as minus 7. So y equals to 3x minus 7 is from equation 1. And now it is isolated for y. So now I can plug that into equation 2. So equation 2, I have 12x equals to 4y plus 3. What I'm going to do is I'm going to plug 1 into equation 2. So if I do that, I should have 12x equals to 4. Now instead of writing y, I would write what y is equal to in equation 1, which would be 3x minus 7. Now I continue on and add my plus 3. Now, when I simplify this down, I still have 12x on the left-hand side, but from the right-hand side, I'm going to multiply 4 into 3x and multiply 4 into negative 7 because I really want to get rid of my brackets. And if I do that, I should have 12x because 4 times 3x is 12x, and 4 times negative 7 should be negative 28, and now I add my plus 3. Now from here, what I want to do is I want to add up my like terms. So because on the right-hand side, I have negative 28 plus 3, I would add those together, and negative 28 plus 3 should give me negative 25. Okay, now from here, because I only have the variable x, I actually want to isolate x by itself. But I noticed one thing here. Let's say I want to move all of my x's to one side so I can start isolating. So I'm going to start by moving 12x from the right-hand side to the left-hand side. But if I subtract 12x from the right-hand side, I have to do it to the left-hand side as well. But then once I do that, you realize something. 12x minus 12x is 0. And 12x minus 12x is 0 on the right-hand side as well. So I have 0 equals to 0 minus 25. So what I'm actually left with is 0 equals to negative 25. Now this actually doesn't make any sense because 0 can't equal to negative 25. In fact, 0 can't equal to any constant other than itself, right? Which is 0. Like 0 equals to 0 makes sense, but 0 equals to any constant doesn't make any sense. So 0 cannot equal to negative 25. And because of that, I would write that as, since 0 cannot equal to negative 25, we have no solution. So this is a case where we have no solution. So when we have no solution, I can also write this as the squiggly brackets, but it remains empty, kind of like how you see in the textbook. And when we have no solution, just as an addition, we have parallel lines. And you can confirm this if you want to. So if you want to take equation 2 and isolate for y, and once you do that, if you do happen to get an equation with the same slope, meaning parallel lines, then you know that there's going to be no solution.